So good morning students, welcome back. Today in this chapter motion in plane in 11th class, we are going to start one of the most important topic, projectile motion. Yes, projectile motion. So very first thing is, what is projectile motion? Look at students, whenever we throws an object with some angle with horizontal, okay, and with some initial velocity. Whenever he throws an object making some angle with horizontal as well as with some initial velocity, and after that the object travels, executes motion under the influence of gravity, such motion is said to be projectile motion. Okay students, and the particle that we throws is said to be projectile, okay. So simple, whenever we throws an object making some angle with horizontal and with some initial velocity, okay, and after that the object travel under the influence of gravity, finally it will reach to the ground, such path, such motion is said to be projectile motion. Okay, in this lots of examples are there. Suppose when the athletes throw the javelin or discus like this, such motion is also said to be that is an example of projectile motion. Lots of examples are there. When a cricketer throws the ball from boundary line, okay, towards wicket keeper, such motion, look at, he throws like this, such motion is also said to be projectile motion. Whenever he throws something from the running train outside from window, okay, that is also an example of projectile motion. Now students, we'll discuss different cases in projectile. Our first case is the path of the projectile. What should be its path when it executes projectile motion? That is also said to be trajectory. Okay, so let's start with diagram. Consider an object is executing projectile motion, making angle theta with horizontal, that is x-axis, and that is y-axis vertical. Initial velocity is u. We took two component of velocity. Horizontal component is taken as ux equals to u cos theta, and vertical component of velocity is taken uy equals to u sin theta. Okay, A is the highest point of motion, and again it will reach to the ground. Okay, from O to B. This is called range. Maximum distance along x-axis is said to be range. This is the maximum height till which the object reach at the point A. Time taken to reach at highest point is called time of ascent. Time taken to come down again on that ground from highest point to ground, that is called time of descent. Okay, and look at this. When object reaches to the highest point, it will stop and then return. That's why its final vertical velocity is 0. Vy is said to be final vertical velocity. Whenever it throws the object in upward direction, it attends to the highest point. Okay, stop for a few for a billion part of second we cannot see, and it returns to the ground. So that's why it's up at upper point, highest point. Final vertical velocity will be 0. Okay, this is range, this is height, and total time is called time of flight. So very first case we are having, that is its path, that is called trajectory. Okay, we'll find what should be its form. And one more thing, when we throw the object upwards, that is opposite to gravity. That's why acceleration along y-axis will be minus g. Why we use minus sign? Because we are throwing the object opposite to the gravity. And ax equals to 0. What is the meaning of ax? Acceleration along x-axis. Particle is moving vertically. No doubts, it finally reaches to the ground, but it is moving vertically. There is no motion along x-axis. That's why acceleration along x-axis should be 0. U is initial velocity. We took two components, horizontal and vertical. U cos theta horizontal, u sin theta vertical. Now students, we have to find path. So we will use second equation of motion. What is second equation of motion? S equals to ut plus half at square. First of all, I am going to convert this equation along x-axis. So along x-axis, distance should be taken as x. Velocity and acceleration should be ux and ax. Velocity along x-axis, acceleration along x-axis. And we know what is horizontal component of velocity. Ux equals to u cos theta. Ux replaced by u cos theta. Time is t. What is ax? Acceleration along x-axis, that is 0 because particle is moving vertically. So this part becomes 0. We have to find time x divided by u cos theta. We got the time Okay. Now after that, we'll write, okay, for this path along y-axis, we have to convert the equation, second equation of motion along y-axis. Then it will replace as sy, uy, ay, t square. Sy means distance along y-axis, uy means velocity along y-axis, and ay means acceleration along y-axis. Distance along y-axis taken as y. What is uy? Vertical component of velocity. Uy is u sin theta. So uy replace u sin theta. Time that we found by second equation, x upon u cos theta. Time replaced by x upon u cos theta. Half as it is ay, that is minus g. Time x upon u cos theta. Square is there, that become x square upon u square cos square theta. U and u cancel out, sin by cos tan theta. X as it is minus plus minus half, that is g u square cos square theta and x square. We got the equation that showing path of the projectile. Okay, that is representing the path of the projectile. And this equation is similar to the equation of parabola. The equation of parabola is y square equals to 4x, general form. Okay. So this equation is similar to the equation of parabola. So what should be the path of a projectile motion? It should be a parabolic path. This is the form of parabola. This, either that, we can make this also. So this is the form of a parabola. That is the equation of parabola. This is similar to the equation of parabola. So that's why whenever an object executes projectile motion, its path should be parabolic. That is our first case. Okay, students?